Hi everybody, this is Katie and welcome to Learning Module 4, which is going to cover Chapter 3 of our textbook on using methods, classes, and objects. So what we're going to do in this learning module, or in this video, is do the code with me to walk through the important parts of the chapter. Now I've already launched JGrasp and I have nothing open at this point, but I'm going to create a new project. Launch JGrasp, and I'll do File, New, Java. And what I'm going to do here is in Blackboard, if you're getting tired of typing and retyping things, I made a new link over here on the left called Tips and Tricks. Excuse me. And one of the things that I posted in there is a skeleton, and it has just your basic information. So I'm going to cheat a little bit. Well, not cheat, but I'm going to copy from here and go back to JGrasp and then paste in there. And then I can fill it out. So, oops, this needs to be cleared. This is the start of my Code With Me program. So before I start typing, I'm going to save it. And I'll save it in my normal location. You can save it where yours are. I'm going to call this CWM4 assignment, and it will again add the extension. Now, I've heard from a few people when you're attaching your programs in Blackboard, you cannot use Internet Explorer. It will not work. You have to use Firefox or Chrome or something different. But Firefox is the recommended and preferred browser for Blackboard. I think they change it all the time, but I know it's definitely not IE. Now when you name your file here, make sure that your class name matches your file name. So I have left this spot blank, public class, and I'm going to name this CWM for assignment. Has to be the same thing. And I'll fill out the basic information, who you are, the date. This is what date it currently is for me when I'm making this, and this is Code With Me Chapter 3 on methods. Excuse me, learning how to use methods, classes, and objects. Now, one of the things that I left in the skeleton was the import java.util.scanner, and I left it there because we'll need it. Anytime we do input, we need that, and we also need our scanner input device. So I called mine input device. You can call yours something different. This is an object of the scanner class that is part of the scanner utility that we imported into our program. So we need to have that in order to do input. I added a few other comments here. So we need this. We have our class name, and again, remember it matches the file name. We are going to, between our public class start, which is here, and before main starts, I left a note here that this is where we would put public variables that can be accessed by any method or all methods. One of the major concepts in this chapter is the difference between public and private variables. So we'll look at both of these and where to put them. And it depends on what you want to access. So here's where you put public variables, and then we have main. I have nothing in here. I'm still going to have code, or I could still have code, but primarily what we're going to do in here is we're going to add method calls, and these would create, our methods would be put down here between the end of main, but before the beginning of our class, the end of our class. We would put our methods here, and then I have a spot for sample output. So to talk about some major concepts or to go through the textbook, starting with page 118, methods, calls, and placements. You need to read this material. I don't want to I won't, I know I said this before, but I'm not going to take an hour and 15 minutes with this Code With Me video. I need you to read the chapter. Well, actually, we might not even. We have 2 chapters on methods and classes and objects. Chapter 4 is more in depth. So we may, we'll get into variables and overloading values and passing things around in chapter 4. But this chapter is huge. So chapter 3, when we start talking about methods, this is a new way to program for object-oriented code. All of your newer languages are OOP, object-oriented programming. And it is just a way to design your program, and they all work around this concept of something called classes. So we have a class, and this class is called Code With Me Assignment. And then inside of here we have methods. So let's see if we have a common example. One of the, well, they do a nice job in the book talking about a class for raises and stuff, but one of the common examples is either like a car class or a dog class. So let me pull up Word and just something different where we can kind of draw this out and talk about the concept. On page 118, computer's slow today. On page 118, it defines all of these things. So what we do, again, I just want to get out of the environment for a minute to explain these, but we would create a class, maybe a class called Animal. And ignore, I am not coding properly, I'm doing pseudocode so you can see the concept. So in our example, we called it Code With Me Assignment 4. But we create a class called Animal. And then inside of here, we have our main method. And in our main method, everything centers around here. So we'll put our method, they're called method calls or invoking a method. And this is explained in the beginning on page 118, 19, and so on. You can have variables can be here, and then you can have variables inside of methods, and they become local variables. They can only be inside of there. So here is our end of our class. So we have this class called Animal, and then we want to create some user-defined methods. So maybe void, it would be defined similar to main, but maybe, well, I'll just say, we'll look at the syntax exactly in a little bit when we code, but say method, this is my dog method, and I would open and close it. And then I would have another method for cat, and then open and close it. And then another method for fish or what have you. So you could have a bunch of animal methods, and they're all defined within this one class. This tab over, yeah. Okay, so we have one class and different methods. What we would then do is create something called an object. An object is a variable, but it's of a class. So instead of creating a small variable, we would do something like, I want to create an animal, and I want to call it my dog. And then I want to create an animal and call it my fish. I don't want a cat right now. This would be an object of the data type animal. It's the class that I created. This animal, my dog, is an object. And I could have other methods like method go for walk. open, close. Method, feed animal. I'm adding some more methods to kind of explain this. So let me tab this over. Okay, so we have different, this is the end of main. We have different methods. Go for a walk, feed animal, dog, cat, fish. So I create objects, my dog, my fish. And then I want to do things with those objects. So I say, okay, what if I want to take my dog? So I would say my object, or my dog, dot, go for walk. And what your program would do, this is what this part is. It's method calls or invoking a method. I would take my object and I would go down here and do everything that's in here. Ignore my spelling. So take the dog, put him on a leash, go for a walk around the block, pick up his poop, and go back. And when this is hit at the end, we come back up here and we go to the next line. So maybe now I want to say, okay, time to feed my fish. So I would say my fish dot feed animal. And then it would, my code would, after I've done back from my walk with my dog, I'll take my fish and I will come down here and do the steps that it takes to feed the animal. Well, then I come back to main and my dog says, hey man, you're feeding the fish and not me. I'm your best friend. So let's say my dog wants to eat. So we would say my dog dot feed animal. And it uses the same method as I used to feed the fish. So I'm reusing code. I'm not reinventing the wheel. I'm not writing different processes. I'm coming down here to feed the animal, and it could be my fish, my dog, my cat. It's all the same things. But some things could be unique, like dog. Dog has different processes in the morning or maybe different things that you store about the dog, like shots, or I don't really know much about animals. Well, it's something that's with a dog that's unique from other animals, like only dogs have. I don't know, cats have shots too. Fish don't have shots. But, you know, something that would be just for a dog. Maybe dog park. You can't bring a cat to a dog park. So we'll say dog park location or something like that. And cat will put clawed or declawed. I don't know if you declawed dogs. I don't have animal. I have a fish. That's it. My son does. But you know, we'd store things that were specific to that type of animal that weren't things that they could share. So we could maybe do something here like, is this freshwater or saltwater fish? You know, these things, the things that we would do in these methods would be unique to that. But then we have methods that we can reuse, things that are the same, like going for a walk or feeding the animal or cleaning their bed. You know, the bed could be the tank or the dog bed or the cat house or whatever. So we can, you'll notice in main, we're reusing some things, but if I want to find out what my dog's park is, I would say my dog dot dog, and it would go down there and get its park. Or my cat dot cat, and it would go down to that cat method and find out if it was clawed or declawed. So I'd have to create an object for each one. So I create my cat. So I create an object for my dog, my fish, my cat. Those are all objects. and then I take, I find out, I go in down here and do what's in this method, which is what is the dog park. It would find that out, and then this one would be clawed or declawed, and then I take my dog for a walk, and then I feed my fish, and then I feed my dog. And if you had another dog, who would have two dogs? That's insane. My second dog, I would create a separate object for that. So what dog do you want to take for a walk? You want to take both of them? Then let's take my dog for a walk, and then let's take my second dog that go for a walk. So you can take any object, you create different objects based on your class. So the data type of these objects is the class name. And then with these objects, my dog, my second dog, my fish, my cat, we have them do methods or invoke methods. Go for a walk, feed the animal, figure out if it's clawed or declawed. It does different processes. So it goes from main, everything centers around main, does something, goes down, comes back, goes down, comes back, and then when the end of main is hit, the program ends. So that's the major concept of methods and classes and objects. A method is a small piece of, well, not small, but it's a piece of code that does a specific thing. So we break our code apart into multiple methods so it's easier to operate. Now what we're going to do with our code with me 4, hold on one second, I'm going to pause just for a minute and look at something real quick and then come back. Okay, I just needed to get to see exactly what was covered in this chapter. I'm real prepared, but this is going to be a good code with me. So let's start coding. We've got the basic concepts, and there are a lot of things in this chapter again, so make sure you read it. But what we're going to do is we're going to start by coding the program on page 8, on page 173. We're going to program chapter 3, exercise 8 on the insurance program. Excuse me. Basically with this program it says a Harrison insurance company computes annual policy premiums based on the age of the current customer and the current calendar year. So what our program is going to do is take in a couple inputs, and then it's going to calculate what the premium is based on their birth year. Now we're going to keep things simple in the beginning. We have the rest of our programming careers to keep coding with objects, but we have another chapter on classes and objects and constructors and passing variables around local and global and all of these things, so we'll cover it in depth. But we're going to just create one method inside of this to solve this problem. So the first thing is we need to identify what we're still going to follow our basic process. Remember our step 1, we have input. Our step 2, we have some sort of, our step 1, we're going to declare our variables. We're always going to do that. And then our step 2 is input. And then we have some sort of calculations or processes. And then step 4, we have something that we want to output. So we're still going to follow those steps. We're just going to do them in a different order. Now, global variables will go up here. There's a time for global variables, and we'll talk about that. We'll talk about that as these next 2 chapters go on. But for our assignments, you can kind of follow this structure. So we're going to keep them as local as possible because it hides our data better. It protects our variables. So inside step 1, inside of main is where I'm going to start coding. So step 1, same thing, declare our variables. Same as our last program. Now what we need to do is figure out what our variables are. So I'm going to break this apart into, I always ask the question is, when I'm coding, what do I have, and I'm writing down as I'm talking, because you should be doing the same, this is important, but what do I have to input, and then create a variable for that, and then what do I have to calculate, and then create a variable or variables for that. So let's read the program together. The insurance company computes annual policy premiums based on the age of the customer turns in the current calendar year. The premium, this is how it's computed. For example, a 34-year-old would pay $360, which is calculated by adding the decades 3 to 15. So since it's 34, it'd be 3 decades, and then 2 15, and then multiplying it by 20. Write an application that will prompt the user for current year and birth year. So we're going to, that's our input. So we're going to have a variable that will be current year, and then we're going to have a variable that will be birth year. And then we're going to pass those to a method that calculates and returns a premium. So we're going to have a calculated variable called premium. So based on the description there, I have 3 variables. Int current year, I like to set mine to 0, so I'm like that. Stores the, you don't have to do all this documentation, but stores the current year. Actually, I don't need to document that, it's pretty self-explanatory. Int birth year. Now these are integers because they're whole numbers. We don't have a half of a birth year. No halfies in here. No current year. It's just, 1984 or 1992 or whatever it is. And then we are calculating our premium. Now, the example they gave us was an integer. I'm more comfortable with calculating this as a double, because premiums, in my opinion, are never on the dot. So it's one idea with money, I always make it double or float, so double makes me feel better. I'm going to do that. Now, okay, I have to have my scanner input device. That's there because I want to take in values. So now I'm going on to my step. Actually, just to keep this out of the way, I'm going to put it, just copy and paste and put it at the beginning of main, so I can still see my steps. And let me cut this out for here, just to kind of simplify things. So I'm going to do step 2, and that is my input. Now you can break this apart into multiple methods, like an input, a calculate, and an output method. But we're not going to do this at this point because we need to learn how to pass variables as references and not as copy variables. So there's pass by value and pass by reference, which are talked about in the next section. And we're just going to follow the rules of this, where we just create one method called calculate premium. So I'm going to do my input right here. So I'll say system.out.println, enter the current year, and then I will put that into my input device. So current year equals input device dot next int. Remember, it's an integer, so we're going to do next int. And then I'll ask my next question. System.out.println, enter your birth year. And then birth year equals input device dot next int. Okay. Now we go on to step 3, our calculations. Now this, and then we also have our step 4, which is our output. So we're still following our sequence structure. Now, with our calculations, this is where the program or the problem says pass both of our variables to a method that calculates and returns a value. So we need to learn how to return a value and also how to define a method. So before I do my call, let's go down here. I'll put my call here in my calculations. But because the program says make a method, I'm going to do just that. So I'm going to create public static double, explain these in a minute, and then I'm going to call my method calc premium and open it with curly brace and close. End of method. Let's stop right here. You'll notice with main, public, static, and then a data type. Here, public, static. Those are keywords that define a class. But what you'll also notice is I have this listed as a double. And that data type, this is called a method header. It's all explained in the book, so make sure you read it. It's a method header. And the data type has to match what you're returning. So you can take a value. I wonder if I deleted this. You can take a variable from here, send it down, do something with it, and send it back. And that's called returning a value out of, returning a value out of a method. We will do this with all of the assignments for this chapter. You'll look at many different examples in this chapter. It's super important to read. I've said that like 10, 15 times now. So the data type here is going to either be a string or an int or a float or a double or a long or a short. It's going to be a data type, and the data type matches whatever we return out of it. So return, and then I'll just put here, return something, a variable. What are we returning out? Well, we're trying to calculate our premium, so I'm going to return my premium from this method. There are, and then a semicolon here. There are rules for naming methods. Be sure to read that. The rules for naming methods are the same pretty much as the rules for naming variables. Name it something that it represents. No spaces. Can't start with a number or special character. Calc premium is a good method name. I know what this method is doing. And then what also I can do here is pass arguments into this method. Okay, so in the parentheses, this is where we pass arguments into a parameter list. So that what we're defining here is a parameter list. This is explained in the book as well on page 127, where it says adding parameters to methods. When we want to pass a value from our method call. So up in main, I'm going to calc my premium. I'm going to call this method, and I'm going to pass it my two arguments, current year and birth year. So this is a method call. So I'm basically, or invoking a method. I'm taking these variables, these values, and putting them here. This is called an argument list of the premium. And then I'm passing them down into my method. So I need to accept them. The way I accept them is by putting the data type and then the variable name. So int cur year, comma, int birth year. Now they have to be in order of how you pass them. So current year goes into current year, and birth year goes into birth year. Notice there's a list in the book that's very useful of do's and don'ts when defining a method. But notice in my call, I don't have any data types. In my header, I have data types all over the place. There's no semicolon at the end of a header, method header, but we have parentheses right here that allow us to put our parameter in there. So these are called arguments. This is called the parameter list. And it's a place setting for, I'll write that in here. It's a place setting for the arguments. Where are they going? What are we going to reference them in here? So now, here I'm returning premium once I calculate it. So this is really continuation of step 3. I'm just taking the process from up here and putting it in its own method. So after I calculate my premium, I'm going to take that value and send it back to main. So I have variables here I take in, then I take those values and send them down. I do something with them, I calculate premium, and I send it back to this place. Well, when I send it back, I have to have it go somewhere. So I say premium equals this call. So whatever this function returns gets stored into this variable called premium. Well, guess what? I keep saying functions. It's functions and methods. Functions are methods that aren't in a class. Methods are functions that are in a class. So the terms are used. There's a difference, but I use the functions a lot too. Sorry. But anyway, premium, this calculate premium method calculates the premium. And then it sends it back and it stores it into the premium variable so that I can, down here, then display my output. System.out.println. Well, let me show you printf because I've talked about it, and this is a decimal. So I'll say printf, the premium is, add a $sign, so it'll do that. And then, I don't know if that'll mess it up. I don't think so. I want to do 2 to the right of the decimal, so I'll say %.2f\n for my new line, and then end the string literal, and then printf uses a comma instead of a plus, and I'll say premium. I posted this also in the tips and tricks and explained some of it. So there's my output. Now step 3, we haven't calculated anything yet. I'm going to create some local variables to calculate the premium. And the premium calculations are explained in question 8 on 173, but basically the formulas, we would create a variable called addition factor and factor, and this is that 15, and then we would create one called multiplication factor. This is just how we calculate the premium, and that would be 20. And then the current age is going to be equal to the current year minus the current, what did I call it? Birth year, I'm sorry. So we have to calculate the age, and we'll do a decade. And that's going to be the age divided by 10. And then the premium, finally. Whoops, which is not an integer, it's a double. And it's already, well, we're going to create, let me explain, this is kind of, let's do the calculation first. So premium is going to be the addition factor plus the decade times the multiplication multiply, what did I spell it? The malt factor times the malt factor. Okay. The addition factor plus the decade times malt, okay. And then we're returning premium. Now, we will get into different ways to return values and the concept of scope, but here's a variable called premium, and it's declared as a double, and here's a variable called premium, and that's declared as a double. Now, why this works is because we have different scope. This premium is used in Maine, and this premium is used in my calc premium method. So because they have different scopes, it won't be a problem. Now here, if this is confusing, these calculations, it's explained in question 8, and that's part of the process. Like, how am I going to calculate the premium? So it has two factors, the 15 and then the 20, and it explains it to you. So let's run it and see what happens. See if we calculate our premium properly. But the concepts are here. I mean, the basic structures, we have Maine, we have our 1, 2, 3, and 4, but now with step 3, I'm going out to this method, doing something, and coming back. So you can have multiple methods. In fact, for your assignment, you will have multiple methods. Oh, let me run my program. So we'll take a look at how printf works as well. I have no syntax errors. Now let me just scroll through my program for you. You can check if you have syntax errors. Remember, just double click, follow where your error is, try to resolve it. You might have to go back in the video if you've made a syntax error to fix it. Just scrolling through mine real quick so you can see it without having to go back. Okay, that's all my code. Okay, let me run. Go over to my input-output. I'm going to enter in the current year, and I'm going to use their sample they gave. For example, a 34-year-old woman would pay, so, well, I'd have to know when she was born. 30. So let me think. This is 20, enter the current year, 2014. What would that be, 1980? I'm not going to get my calculator out. I think this is right. So if today is the current, if 2014 is the current year, and she was born in 1980, that would make her 34. Okay. The premium is $360, and that's exactly what the input or the sample output gives you in question 8. So let me just run one more time. I'll throw in my information to see what my premium would be. So it's 2014. It's born in 1976. Would be the same. Oh, because it'd be the same decade or the same variance. Let's throw in a younger kid. So 2014 and 1995 premium is cheaper. That doesn't seem like that should be it. Oh, this is life insurance. I'm thinking car insurance. Okay, life insurance would be cheaper for a younger person and or more expensive for an older person. I was like, why would a 19-year-old kid have cheaper car insurance? Let's run it for someone older. This is kind of fun. This is the testing phase of our program. What did I click? Run. Okay. Oh, let's see. It's 20. I'll do my mom. She'll be happy with that. 2014, and she was born in 1952. Her premiums are $100 more than mine, just because she's older than me. Oh, the absurdity of that. Okay, making sure you copy your sample output. This is the, and include it in this program here. Sample output here. And I'm going to stop now for the code with me. Read the chapter. Make sure you read the chapter. Save this, go into Blackboard, and make sure you upload it into the code with me of your learning module, wherever that may have gone to. And then I will work on assignment 4. Come on, Blackboard. I will work on assignment 4, which will be chapter 3, and we're going to do one of these questions on page 174. But as part of that assignment, I'll make a quick video that will set you up for the structure of it. So obviously you've done the quiz, you've done the code with me, and the next thing is learning module 4 assignment, which I'll make an assignment for. So thank you. Have a great night or day or morning.